This is question number 16. We have a arrangement where we have a battery with EMF E and internal resistance R, and in that case, and when the switch is S is open, the voltmeter reads 1.52 volt, and when the switch S is closed, the voltmeter reading drops to 1.45 volt, and the ammeter reads 1 ampere. Find the EMF E and the internal resistance of the battery. Let's see what's happening on in the circuit when the switch S is open. The current starts flowing through this. There is no current can flow through this, so all the current flows through this, and this is the circuit that it completes, and the voltmeter V, it reads the voltmeter across this point. But they say that the voltmeter resistance is very high. And what does that mean? It means that because this resistance is very high, there is negligible current flowing in this circuit. And then we can see V is equal to E minus IR. Now I is going to be so small that this term, whole term, gets very small, specifically because this resistor R is the internal resistance of a battery, which is R is very small. This is small, this is very small, so that this term becomes negligibly small. So this voltmeter readings reads the same as the EMF of this battery. As a practical example, it's not part of the question, but it is a practical example. Let's say V is equal to 1 volt. This E actually is equal to 1 volt. And then we have a 1 ohm internal resistance. It's a typical resistance of a good battery, even less than 1 ohm, but let's say it's as high as 1 ohm. The resistance of this voltmeter is 1 mega ohm. It can be higher, but let's say it's 1 mega ohm. And the current flowing in this circuit is going to be this V divided by this resistance plus this resistance, or 1 plus 10 to the power 6, or about 10 to the power minus 6. So the voltmeter will read the reading V, that will be given by 1 volt minus 10 to the power minus 6 into 1. And you see this is 1 by 10 to the power 6. 1 minus 10 to the power minus 6 is about 1 volt. What it means that the reason I wanted to show you is that this voltmeter reads about the same reading in an open circuit. The voltmeter reads about the same reading as even if you connect a small resistance in series. You can do this practice. If you have a voltmeter, connect a small resistance in the series, and the voltmeter will read about the same. Now, the next question is, why does the voltmeter reading drop when you connect an ammeter like this? The ammeter has to read the reading of the current flowing in this circuit, and that current will be substantial because of this resistance R and possibly some internal resistance of this ammeter. Now, because now the current starts flowing in the circuit, there is going to be some drop across IR. Now we cannot neglect the drop across the resistance IR, and that's why the reading here will be a little less because of this IR drop. So when the switch S is closed, we have V is equal to E minus IR. Again, we are considering only this loop because the current in this loop, the upper loop, the current there is no current flowing in the upper loop. Now it reached the current voltage reading 1.45. That will be equal to 1.52 minus the current flowing in this resistor, which is 1 ampere, that is measured by this ammeter. So 1.0 ohm multiplied by R. So we can find R by taking this whole thing on the left and this whole thing on the right. So 1R is equal to 1.52 minus 1.45, or 0.07 ohm. So anytime you are applying a voltmeter across any resistance or any voltmeter, you can expect to measure it the same voltage if there no other circuit is connected across it.